All right, high energy, loving it. Today, everybody, we are going to start 5.3. Just kidding, we're in chapter 7 in this class. 7.3 is our focus starting today. Now, about every other week I get these emails, so don't worry, I want you to know I do read these emails and I take them very specific and I make note of it. So due to popular or by popular demand, we're going to do 7.3 and our focus is back to this wonderful idea of proving figures similar. All right, so if you happen to be working on something that's not geometry, I'm going to say I need you to be working on geometry for the time being, but let's knock these out. Now, when we prove stuff similar, the cool thing is we're not going to have to take a wildly different approach than the way that we did it with congruence. Now, I don't know that I love the way your book approaches it, and I think we went through the exact same thing with congruence, where the congruence transform to show there's a rigid motion, it's a fine way to do it, but it only works if you have really clear graphs, really specifically put on the coordinate plane. If we have stuff floating out in space, it doesn't work anymore. So, as we're going through these, here's my first question for you, and this will just be a little warm-up here. You are going to physically stand up and go talk with somebody that you don't normally for this question. Everybody will be standing. You can just chat it out, but I want to hear you guys talking and hopefully arguing whether or not the following is true. So you don't even have to write this one down. Only question at hand to start with is, here's two triangles. Between you and I lied, I'm going to make you guys stand up, and you're going to work this up at one of the whiteboards here. You can erase a bunch of stuff there. We'll just do it this way. We got how many? 2, 4, 6, 7. Unintentional, just for the record. I want Drew, you're going to start counting. And we're just going to go 1, 2, 3, 1, 2, 3. And do we have enough people for that? Yep, we'll have one person be a floater between groups, and I'm okay with that. That's it. All right, Ashley, you get to jump between groups. You're going to be like the messenger here. Ooh, there's a Greek god that was a messenger the other day in our vocab. Anybody remember who it was? Hermes, thank you. Awesome. Cool. So check it out. The ones. I want you guys to come up to this board. If you were a number 1, you're going to come up to the board behind me, and your only question, and you can step back, is, are these similar? The 2s, you're going to take that board over there. The 3s, you're going to take the far right board. I will clear off some of these things. Up on the board, I need to see you and your neighbors work. Now, we're going to ease into this, and I'm going to start doing a lot more of this in the future, but I'm getting practice because I'm new at this. So here's the only rule. When you're working, hypothetically, when the 1s are together, one of you is probably going to be holding a marker. When you're holding the marker, you're not allowed to talk. The only person that can talk is your group mate, or Ashley, if she's floating between groups here. You can only write down what your teammate is speaking, which means if I hand this to Carson and he knows how to do the problem, he's going to be tempted to just work the whole problem without ever consulting anybody else. Not my goal. I want Carson to write down whatever who he's working with says. Cool, cool? Okay, we're going to try this. It's going to be like 3-ish minutes. This one problem's all we need. I'll add more to it if we need to. But 1s, I'll have you up here. So whoever's 1s, here's the 1 spot. And I'll grab you an eraser. I'll toss you an eraser. You guys can clear the board. 2s, you're going to come here. And 3s, you'll be whichever board you'd rather work with. Let me find another eraser here. I had towels and people stole them or moved them. And now there's one there. Here you go, Kristen. You erase something there. I'm going to sneak behind you. We're going to pause the video so Lily doesn't just have to listen to silence for the next however long. Cool. If we look at all 3 of your guys' work, the only thing that I see changing is the order with which we work. Now, if we don't specify that one of these is the image and the other one is a pre-image, because we can't use that language until we know they're similar anyway, because we need a transformation, they don't specify. If I see a problem like this and doesn't specify, I'm always going to say original on the left and new figure on the right. It's just my default because it's how I read. It's how we do numbers. But if you do it the exact opposite way, you're still good. This group, love the fact that they did it the exact opposite way, which is completely fine. They got 5/4 as their scale factor. Were they enlarging or reducing? Which way did they go? Left to right or right to left? left to right. Other group got 4/5. It's the exact opposite. They're not wrong. How did they interpret this problem? They were doing it right to left. They're seeing a reduction. Now, the other part, after each of you were able to show me that all three sides had the same ratio, which is really just a long way of saying all three sides are proportional, then I asked you guys one more step, and I asked you to write the similarity statement. And that's all that I give you guidance for. Now, this one, if you don't recall the language, it's reasonable. The triangles are similar. This is a statement that says they're similar to each other. I agree with you. Don't know that that is exactly what I'm after or what I was after, but I do agree with that statement. Carson, I like this one. I didn't look at the letters. But when I ask for a similarity statement, I'm much more specifically asking for the statement, the mathy statement that says this triangle matches up with this. Does the order with which we talk about these triangles matter? For sure, because this shows me that if I were to take AB over DE, and I'm just using first and second, that ratio would have to be the same as BC over EF. And we can switch these around, right? Just like we do with congruent stuff. Now, the cool part of it is when we did congruence initially, we started by saying, let's show that all the sides are the same and all the angles are the same. And then once we have everything is the same, 3 sides and 3 angles, or however many sides for whatever polygon, then we started doing some kind of streamlined shortcut stuff. Did we have shortcuts for triangle congruence? So let me rephrase that question, and I didn't even give you time to think about it because I don't like the way I asked it. What were the shortcuts that we had for triangle congruence? I'm going to cold call in about 30 seconds. So if you're not sure what they are, chat with your neighbors. 4 shortcuts for triangle congruence. Snake jazz. Ooh. Okay, I've heard this group say several of them. Camille, can you give me one of them? SAS. Now, I have a friend that teaches high school math and does not let people use SAS. He makes them right side, angle, side every time. I might start doing that next year. You guys dodged the bullet. Give me another one, Vincent. SAS. So I'm going to spell that. What's SSS for? Side, side, side. Andrew, can you give me another one? Saw. Angle, side, angle. And the last one? ACE. AAS. Now, I say the last one, but there might be another one that's living over here. If it's a right triangle, what are the shortcuts? Or what is the shortcut? Okay, I am apparently really good at lip reading because Ashley says hypotenuse leg. Now, we can count it as its own for right triangles. Does anybody recall what that HL shortcut really is? So it is the hypotenuse and leg. But if I give you a right triangle or any right triangles, and you know the hypotenuse and a leg, could you find the third side? So we really have a special case of side, side, side happening. Catch that, Carson? Did you catch it, though? Give me anything that I said. Okay, so answering no is a more appropriate way to answer if you don't catch. I'm obviously calling on you because I don't think you're paying attention in that situation. All right, now, for our purposes, my big question for you is, these shortcuts worked for what? These were all the shortcuts to show 2 triangles were congruent. So right off the bat, just a nice big question. Do these shortcuts work for similarity? Now, as we're going through this, I'm torn on the way that I really want to knock these out. We'll just do a quick little check here. Do you think that if I give you 2 triangles, and I guess let's just check them. Anybody have a gut feeling first? Do these triangles, like do the shortcuts that show congruence, do they also work for similarity? You say no? And that's reasonable to think that. Let's try one. Now, I'm going to go in a particular order because it doesn't really matter which ones we take. If we just are wondering this question, let's try a couple of them. So what if we tried angle, angle? Similarity. Now, notice I'm not saying like here's a theorem or anything. We're just saying, is it enough to say that this must work? So let's just pretend like we had something given. If I wanted to be able to think about angle, angle similarity, well, let's just knock it out. I'm going to draw one triangle, and I know how I would like to do it, but it doesn't have to be exactly like this. Here's one triangle. Now, if I want it to be a similar triangle, all I have to do, maybe, I guess we'll work this out, is try to do and check to see if angle, angle is enough. Now, I don't know where these triangles are named, and I've drawn them backward, and I could have drawn them differently, don't need to. Let's say this triangle is ABC, and this triangle, and I'm not going to follow any particular order, is QRT. And notice, you will hear in a second, that maybe I'm doing that intentionally, making it weird. Well, right now, I don't have anything marked. We're trying to see if what works. We're checking some shortcuts. Which one are we going to check first? Angle, angle. So I don't really care what it is. Drew, give me an angle that you want to be the same on both of them. Drew says A and T look to be possibly similar or the same. Do you guys agree? Okay, Camille, give me another one that you think might be. Sure, I'll take it. Let's say that this is the same, and this is all that we're given. And C would match up with what over here? Q. If I give you two triangles like this, do we have enough to decide if they're similar? So I like that you gave me that because that's 180 degrees, little geometry wordplay in there. Opposite of what you said before. Like you'd give me a pretty firm and quick no initially. Carson, I think, claims yes. I'm going to give you guys 60 seconds. Chat with your neighbors. Convince me in 60 seconds that this is enough. Cool. I don't think it'll take you 60 seconds. Convince me that just from this picture that they should be the same. So check it out. When we talk about triangles or any shapes being similar, we use same shape, different size as a common language. Drew, what was your comment a second ago?
A whole triangle has to equal up to 180.
So we're going to pause there. Is that true? When you say the whole triangle has to equal to 180, I want to clean up the language a little bit, but I do agree with you. The three interior angles of every triangle adds up to 180. Now, if I do one arc plus two arc, is that the same as this one arc plus this two arc? So what do we conclude about that third angle? And maybe we had a theorem that was called that. If we put numbers in, it's going to be obvious. And before I put numbers in, who knows the answer right now? But I just didn't randomly call on you. What's true about the third angles, Ashley, do you think? So it could be 60 if we depends on the numbers. I don't know the actual value, but can we agree that whatever it is, it has to be the same on both to add up to 180 for both triangles? Okay. Now you're giving me the logic in the proof there is what you're doing, Drew. So if you're thinking like, oh man, I hate proof, you're doing the hard part of it. You just haven't written it down in the format of a proof, which that's awesome. Okay. What dictates the shape of a figure? Is it the length of the sides or is it the angles? If I give you a 30, 60, 90 triangle, is it going to look like every other 30, 60, 90 triangle? Or if I give you a 60, 60, 60 triangle, is it going to look like every other 60, 60, 60 triangle? So I've seen some people say yes and some people say no. I just want to challenge you real quick. This is a roughly 30, 60, 90. Now, I'm not going to do anything crazy, except I'm going to make a different triangle here. So there's two triangles on the board. Does this angle, as long as I do this the right way, does this angle match this angle? Does this angle match this angle? And does the third angle match on both of them? I think so. Are these the same shape, just one's bigger than the other? So same shape, different size, I think, which I don't even really need to mark that third angle then. If I give any two sides, do we get enough to guarantee that they're going to be the same? Or any two angles, I'm sorry. has to be the same shape, right? I can't give you 3 angles and say make a triangle out of it and then give you those 3 angles to make a different one than me. It can't happen. So I'm okay with this. Angle similarity. This is a shortcut that we have. Now, for these, couple ways we can go through this. I can just really quickly make this an easy and nice theorem here, or we can kind of back up and say if one triangle has 2 angles congruent to, like, can we just use this picture to write our theorem? I'm fine with that. So here we go. Theorem 7.1, and I'll go back to red here just to make sure we get it. Theorem 7.1. We just have a nice shortcut. Angle, similarity. Okay, now we will make this a more theorem-y feeling thing just a little bit. If 2 angles of one triangle are equal to 2 angles of another, and I'm going to say another triangle to be super specific, which is exactly what we have going on here, then what do we conclude about those triangles? And I'm going faster than you guys can write, and I can tell that. Hey, then they are similar. Now, I'll write the word similar out, but I would encourage the tilde if I were you guys. So all of a sudden, we get another shortcut, or a shortcut for this. Instead of finding that transformation with a dilation involved somewhere, we can just say, hey, 2 of the angles match 2 of the angles. Now, fortunately for us, that's nice and handy. Unfortunately for us, if I don't give you the angles, we don't have a nice way to solve this yet. Okay, so angle worked. Sweet. What one do you want to check next? Sure, like let's just check it. I want to know the same thing here, and I'll just switch color between these. Side, side, side. And I want to see how I wrote it this other one. Side, side, side similarity. I'm going to put a question mark. Okay, I'm going to give you guys a little bit of time to be uncomfortable with the math. I want you to try these things. I would sketch out the general triangles like we did on that first one. Like I didn't do anything specific other than I just listed what was given. This one, you're going to assume that what is all the same on each of these triangles that you sketch? The same what? Side lengths. Good. All 3 of the side lengths must match. So whatever picture you wind up drawing, I'm cool with that. I'm going to give you guys 5 minutes to see if we can't check all of these. Side, angle, side, similarity. And I want to know, does that exist? And then we better do angle, angle, side. Ooh, maybe we don't need angle, angle, side. Love that. Why don't we need to check? What are the only 2 we haven't checked yet? Ace, angle, angle, side, and asa. Okay, so really different day. I want you guys very similar to what we did. If you want to stand up and like put your notebook on the board, I'm cool with it. If you can got clipboards, if you want to stand up and walk around, I don't mind where you're working as long as you're working. I want you to do the same thing that we did above and see if we can't convince ourselves that yes, it does, or no, it doesn't work. These 3, I need you to check. Is this true? Is this true? And answer this question by the time class starts tomorrow. Cool. If you need help drawing the triangles, let me know. I can help you if needed. But we're just going to see if we can't work out which one of these seemingly work and which ones don't, or which ones don't we need. And then we'll continue on using any of the ideas that we find now, tomorrow. Do you guys all have an idea of what to draw for your triangle? So if I need 2, and I can draw the same triangles on each of these, just so you know. And I'll just use this triangle and a slightly bigger one here. And I'm going to try to make them look at least fairly similar. It won't be perfect. But if we do ABC and QTM, I'm just randomly picking numbers here. All that we have to change is what we're given. For the first one that we did, and I hope you guys had it, what did we mark on our triangle? Like initially, what did we mark?
How 2 angles.
2 angles. Why on earth would we have marked 2 angles? Because we were checking angle, angle. What are we checking here? So what do you think I should mark? Sides. AB and that side, probably about the same. This side and this side, probably about the same. This side and this side, probably about the same. I want you to do something very similar for the next one as well. Tonight, there's no like formal assignment other than play around with these, decide whether you think that this is enough information to show that stuff is similar or not. Pretty open-ended question, which I know is very different than what we normally do. Just like we played around with the first one, play around with this one. You guys get like 2 minutes to kind of chat with each other here, but we'll jump in at the start of class right here tomorrow. Cool. Draw your triangles, play around with it. If you need to add length, you can. Like I'm completely fine with that. A-okay with it. I'll give y'all a moment.